Bazooka is the common name for a man-portable recoilless anti-tank rocket launcher weapon, widely fielded by the United States Army, also referred to as the stovepipe. The innovative bazooka was among the first generation of rocket-propelled anti-tank weapons used in infantry combat. Featuring a solid rocket motor for propulsion, it allowed for high-explosive anti-tank warheads to be delivered against armored vehicles, machine gun nests, and fortified bunkers at ranges beyond that of a standard thrown grenade or mine. The bazooka also fired a Hesh round, effective against buildings and tank armor. The universally applied nickname arose from the M1 variant's vague resemblance to the musical instrument called a bazooka, invented and popularized by 1930s U.S. comedian Bob Burns. During World War II, German armed forces captured several bazookas in early North African and Eastern Front encounters and soon reverse-engineered their own version, increasing the warhead diameter to 8.8 cm and widely issuing it as the Raketen Panzerbuchse, Panzerschreck. The term bazooka still sees informal use as a generic term referring to any ground-to-ground shoulder-fired missile weapon. Design and development. The development of the bazooka involved the development of two specific lines of technology: the rocket-powered weapon, and the shaped charge warhead. It was also designed for easy maneuverability and access. World War I. The rocket-powered recoilless weapon was the brainchild of Dr. Robert H. Goddard as a side project of his work on rocket propulsion. Goddard, during his tenure at Clark University, and while working at Worcester Polytechnic Institute's Magnetics Lab and Mount Wilson Observatory, designed a tube-fired rocket for military use during World War I. He and his co-worker, Dr. Clarence N. Hickman, successfully demonstrated his rocket to the U.S. Army Signal Corps at Aberdeen Proving Ground, Maryland, on November 6, 1918. But as the Compiègne Armistice was signed only 5 days later, further development was discontinued. The delay in the development of the bazooka was as a result of Goddard's serious bout with tuberculosis. Goddard continued to be a part-time consultant to the U.S. government at Indian Head, Maryland, until 1923, but soon turned his focus to other projects involving rocket propulsion. Hickman later became head of the National Defense Research Committee in the 1940s, where he guided rocket development for the war effort, including completing the development of the bazooka. Shaped charge development. Shaped charge technology was developed in the U.S. into a shaped charge hand grenade for use by infantry, effective at defeating up to 60 mm of vehicle armor. The grenade was standardized as the M10. However, the M10 grenade weighed 3.5 pounds, was difficult to throw by hand, and too heavy to be launched as a rifle grenade. The only practical way to use the weapon was for an infantryman to place it directly on the tank, an unlikely means of delivery in most combat situations. A smaller, less powerful version of the M10, the M9, was then developed, which could be fired from a rifle. This resulted in the creation of a series of rifle grenade launchers, the M1, the M2, the M7, and the M8. However, a truly capable anti-tank weapon had yet to be found, and following the lead of other countries at the time, the U.S. Army prepared to evaluate competing designs for a more effective man-portable anti-tank weapon. The combination of rocket motor and shaped charge warhead would lead to Army development of light anti-tank weapons. Rocket-borne shaped charge weapons development. In 1942, U.S. Army Colonel Leslie Skinner received the M10 shaped charge grenade, which was capable of stopping German tanks. He gave Lieutenant Edward Ewell the task of creating a delivery system for the grenade. Ewell created a small rocket, but needed to protect the firer from the rocket exhaust and aim the weapon. According to Ewell, "I was walking by this scrap pile, and there was a tube that happened to be the same size as the grenade that we were turning into a rocket. I said, that's the answer. Put the tube on a soldier's shoulder with the rocket inside, and away it goes. By late 1942, the improved rocket launcher, M1A1, was introduced. The forward hand grip was deleted, and the design simplified. The production M1A1 was 54 inches long and weighed only 12.75 pounds. The ammunition for the original M1 launcher was the M6, which was notoriously unreliable. The M6 was improved and designated M6A1, and the new ammunition was issued with the improved M1A1 launcher. After the M6, several alternative warheads were introduced. The 2.36-inch smoke rocket M10 and its improved subvariants used the rocket motor and fin assembly of the M6A1, but replaced the anti-tank warhead with a white phosphorus smoke head. WP smoke not only acts as a visible screen, but its burning particles can cause burns on human skin. The M10 was therefore used to mark targets, to blind enemy gunners or vehicle drivers, or to drive troops out of bunkers and dugouts. The 2.36-inch incendiary rocket T-31 was an M10 variant with an incendiary warhead designed to ignite fires in enemy-held structures and unarmored vehicles, or to destroy combustible supplies, ammunition, and materiel. It was not often utilized. The original M1 and M1A1 rocket launchers were equipped with a simple rear sight and fixed front sight, and used a launch tube without reinforcements. During the war, the M1A1 received a number of running modifications. The battery specification was changed to a larger, standard battery cell size, resulting in complaints of batteries getting stuck in the wood shoulder rest. This was followed by a new aperture rear sight and a front rectangular frame sight positioned at the muzzle. The vertical sides of the frame sight were inscribed with graduations of 100, 200, and 300 yards. On the M9, the iron sights were at first replaced by a plastic optical ring sight, which proved unsatisfactory in service, frequently turning opaque after a few days' exposure to sunlight. Later iron sights were hinged to fold against the tube when not in use, and were protected by a cover. The launcher also had an adjustable range scale that provided graduations from 50 to 700 yards in 50-yard increments. An additional strap iron shoulder brace was fitted to the launcher, along with various types of blast deflectors. The Bazooka required special care when used in tropical or Arctic climates or in severe dust or sand conditions. Rockets were not to be fired at temperatures below 0 degrees Fahrenheit or above 120 degrees Fahrenheit. Field experience induced changes in 1943. Field reports of rockets sticking and prematurely detonating in M1A1 launch tubes were received by Army Ordnance at Ogden Arsenal and other production facilities. At the U.S. Army's Aberdeen Proving Grounds, various metal collars and wire wrapping were used on the sheet metal launch tube in an effort to reinforce it. However, reports of premature detonation continued until the development of bore slug test gauges to ensure that the rocket did not catch inside the launch tube. The original M6 and M6A1 rockets used in the M1 and M1A1 launchers had a pointed nose, which was found to cause deflection from the target at low impact angles. In late 1943, another 2.36-in rocket type was adopted, the M6A3, for use with the newly standardized M9 rocket launcher. The M6A3 was 19.4 inches long, and weighed 3.38 pounds. It had a blunted, more round nose to improve target effect at low angles, and a new circular fin assembly to improve flight stability. The M6A3 was capable of penetrating 3.5 to 4 inches of armor plate. Battery problems in the early bazookas eventually resulted in replacement of the battery-powered ignition system with a magneto-sparker system, operated through the trigger. A trigger safety was incorporated into the design that isolated the magneto, preventing misfires that could occur when the trigger was released and the stored charge prematurely fired the rocket. The final major change was the division of the launch tube into two discrete sections, with bayonet joint attachments. This was done to make the weapon more convenient to carry, particularly for use by airborne forces. The final two-piece launcher was standardized as the M9A1. However, the long list of incorporated modifications increased the launcher's tube length to 61 inches, with an overall empty weight of 14.3 pounds. From its original conception as a relatively light, handy, and disposable weapon, the final M9A1 launcher had become a heavy, clumsy, and relatively complex piece of equipment. In October 1944, after receiving reports of inadequate combat effect of the M1A1 and M9 launchers and their M6A1 rockets, and after examining captured examples of the German 8.8 cm RPZB-43 and RPZB-54 Panzerschreck, the U.S. Ordnance Corps began development on a new, more powerful anti-tank rocket launcher, the 3.5-INCH-M20. However, the weapon's design was not completed until after the war and saw no action against an enemy until Korea. In 1945, the U.S. Army's Chemical Warfare Service standardized improved chemical warfare rockets intended for the new M9 and M9A1 launchers, adopting the M26 gas rocket, a cyanogen chloride-filled warhead for the 2.36-in rocket launcher. CK, a deadly blood agent, was capable of penetrating the protective filter barriers in some gas masks, and was seen as an effective agent against Japanese forces, whose gas masks lacked the impregnants that would provide protection against the chemical reaction of CK. While stockpiled in U.S. inventory, the CK rocket was never deployed or issued to combat personnel. Aviation use. In August 1950, a joint Navy and Marine Corps test used a newly acquired Bell Model 47 helicopter to test if a bazooka could be fired from a helicopter in flight. One of the larger 3.5-inch models of the bazooka was chosen, and was mounted ahead and to the right of the helicopter to allow the door to remain clear. The bazooka was successfully tested, although it was discovered that it would require shielding for the engine compartment, which was exposed in a Model 47 and other early helicopters. The helicopter itself belonged to HMX-1, a Marine experimental helicopter squadron.